What does a loss function actually make a neural network learn? I'm starting a small series where I train the exact same neural network with different loss functions and then visualize how each one changes the model's internal representations. So the first loss that we're going to walk through in this series is the foundational loss, cross-entropy loss. And you can see the equation here. Now, if you aren't super familiar with maths, this may look a little bit daunting, but it's super simple and we're going to walk through it slowly together. So P is the probability that the model currently assigns to each class C, while Y is the target vector, and that tells us what class is actually correct. This target vector contains a 1 at the index of the correct class and zeros everywhere else. So all the values in that vector add up to 1. You can essentially think of this vector as telling the network this is how much probability you should assign to each class if you want to be correct in the future. And with the standard cross-entropy loss, that means putting all of the probability on the correct class. The network then learns which features in that image help it produce that target distribution. For example, when it sees wheels, it's most likely a car. So each Y subscript C is one value from that target vector. Because the correct class has YC equals 1, and every other class has it equaling 0, multiplying by Y subscript C effectively removes all of the incorrect classes from the loss terms equation. Then we have the log term that wraps the probability. This makes assigning a very small probability to the correct class increasingly costly for the network. If the model gives the correct class a probability close to 1, the penalty will therefore be small. If it gives it a probability closer to 0, that penalty will become massive because that's how the logarithmic function works. The sum simply combines the contribution across all C classes, and the minus sign turns the negative log value into a positive value so that the network can try and minimize that number as low as possible. So let's pretend we have a dog image, for example, and our Y label looks like this. One prediction gives us these probabilities. Cross-entropy takes the minus log of the probability of the true class, and so our network in this example gets a penalty of log 0.9, which is approximately 0.1. So it's pretty small and close to 0, so it did well. Does that make sense? So in summary, this loss says for the correct class, maximize the probability as much as possible. So what does it actually do to the network? Well, in this video, you can see the network learning in real time. At the start, the embeddings are basically unstructured. But as the cross-entropy loss trains the model, the classes gradually move into different, distinct regions. And the classifier's decision boundaries reshape around them, as you can see. Interestingly, cross-entropy doesn't actually tell images from the same class to form a tighter cluster. It only actually cares that the correct class wins. So do you want to see more of this? Like this video, follow me, and let me know in the comments.